Hey guys, so in this video we're going to be looking at complex numbers in quadratic equations, but before we do that there are two things that we've got to go through first. The first is called equating the real and imaginary parts of complex numbers. Now don't worry, it's a lot simpler than what it sounds like. Basically, if I have a complex number, say 4 minus 2i, and I set it equal to another complex number which we don't know, so we'll call it a plus bi, what I can then say is that the real part of this complex number, which is 4, is equal to the real part of this complex number, which is a. So a equals 4. Now that's why we call it equating the real parts of complex numbers. And likewise, the imaginary part of this complex number, which is minus 2, is equal to the imaginary part of this complex number, which is b. And so b equals minus 2. For some people this idea is obvious. But if you don't get it straight away, another way to look at it is if I had my original equation 4 minus 2i equals a plus bi, and I put all the real parts on the left side and all the imaginary parts on the right side, so I get 4 minus a equals bi plus 2i, and now I can tidy this up a little and get 4 minus a equals, in brackets, b plus 2 times I. Now by our definition up here, a and b are both real numbers. So that means 4 minus a and b plus 2 are also going to be real numbers. But that means on the left side we have a real number, whereas on the right side we have an imaginary number, because it's a real number, b plus 2, multiplied by I. But how can a real number be equal to an imaginary number? Well, the only way that it's possible is if the real number is 0 and the imaginary number is 0i, which of course is still 0, since 0 times any number is 0. So that would mean 4 minus a is equal to 0, or in other words, a equals 4, and similarly b plus 2 is equal to 0, or in other words, b equals minus 2, which just leads us back to our original answer. So in general, if you have two complex numbers which are equal to each other, a plus bi and c plus di, then it follows that a equals c by equating the real parts, and by equating the imaginary parts, we get that b equals d. Great, so now we're going to use this rule to find the square root of a complex number. Why did I make that Q a capital? Wow, that's going to really annoy me. Oh well, deal with it. Let's try to find the square root of the complex number negative 7 plus 24i. Now how can we do this? Well, since we're trying to find it, let's call it something. Let's call it x plus iy, and then we'll try and use algebra to find x and y. So we can square both sides to get negative 7 plus 24i is equal to x plus iy squared, and now expanding this squared thing, we'll get x squared plus xyi plus xyi plus I squared y squared. And now I squared equals minus 1, so this becomes x squared minus y squared plus 2xy times I. And here we've got the imaginary part of our complex number, and here's the real part. Okay, so what do we do now? Well, now is the time to use our trick of equating the real and imaginary parts. So the real part of this complex number is minus 7, and by equating the real parts, this is going to be equal to the real part of this complex number, which is x squared minus y squared. So we get that minus 7 is equal to x squared minus y squared, and now I'm going to call this equation 1. And by doing the same thing with the imaginary parts, we'll get that the imaginary part of this complex number, which is 24, is equal to the imaginary part of this complex number, which is 2 times x times y. Now I'm just going to divide by 2, so we get 12 equals x times y, and now I'm going to call this equation 2. Cool, so now we have two simultaneous equations, which you can solve to give us x and y. So from this equation, we get that y is equal to 12 divided by x, and we're going to sub this in equation 1, and we'll get that negative 7 is equal to x squared minus 12 divided by x all squared, and 12 squared is equal to 144, so we'll get negative 7 is equal to x squared minus 144 divided by x squared. And now multiplying both sides by x squared, we'll get that negative 7x squared is equal to x to the power of 4 minus 144. And now bringing this negative 7x squared onto the right side, we'll get that x to the 4 plus 7x squared minus 144 is equal to 0. Now this is simply a quadratic equation in terms of x squared. So using our quadratic formula, we'll get that x squared is equal to negative b, which is negative 7, plus or minus the square root of b squared, which is 49, minus 4 times a, which is 1, times c, which is negative 144. And that's just going to make this negative into a positive. All divided by 2 times a, which is 2 times 1. Now 2 times 1 is just 2, and 49 plus 4 times 1 times 144 is 625. So what we have here is negative 7 plus the square root of 625, all divided by 2. Sorry, it's actually a plus or minus, not just a plus. Anyway, so the square root of 625 is 25. So we get negative 7 plus or minus 25, all divided by 2. And now when you put this in your calculator, what you'll find is that x squared is equal to negative 16, or 9. But now we have two numbers for x squared, so which one should we use? Well, let's think. If x squared was negative 16, that means x would be the square root of minus 16, and so x would be an imaginary number. But x has to be a real number by our definition of a complex number over here. So that means x can't be an imaginary number, and hence x squared can't be negative 16, which means x squared must be equal to 9. So x squared is equal to 9, and that means x is equal to 3, or x equals negative 3. And now we just have to find y, and we can do that using this formula that we found before down here. So when x equals 3, y is equal to 12 divided by 3, which is just 4. And now when x equals negative 3, y is equal to 12 divided by negative 3, which is of course negative 4. So by taking this pair of x and y, and subbing it into its x plus iy form, we get that the square root of negative 7 plus 24i is equal to 3 plus 4i. And by doing the same thing with this other pair of x and y, we get that it's also equal to negative 3 minus 4i. And now you may notice that 3 plus 4i is equal to the negative of negative 3 minus 4i. So we can simplify this even further and say that the square root of negative 7 plus 24i is equal to plus or minus 3 plus 4i. Now you might be wondering why we have two answers. And the reason for this lies in the fact that one answer is positive while the other is negative. But when you square both of these numbers, the negative or the positive is going to go away. And so you get the same number, which is negative 7 plus 24i. It's like technically saying that the square root of 4 is both 2 and negative 2. So remember that whenever you have the square root of a complex number, you'll always get two answers. Great, so now we're ready to solve some quadratic equations using complex numbers. So let's try an easy example first. Say we want to solve x squared minus 2x plus 5 is equal to 0. Now using the quadratic formula, we get that x is equal to 2 plus or minus the square root of 4 minus 4 times 1 times 5, all divided by 2 times 1. And now 4 minus 4 times 1 times 5 is equal to negative 16. So this simplifies to 2 plus or minus the square root of negative 16, all divided by 2. So here we've got the square root of a negative number, but we want to change it into terms of I. So the way we do this is by noticing that the square root of negative 16 is equal to the square root of 16 times the square root of negative 1. And now the square root of 16 is of course 4, and the square root of negative 1 is just I. So this simplifies down to 4i. Now substituting this back into our original equation, we get that x is equal to 2 plus or minus 4i, all divided by 2. Now 2 divided by 2 is of course 1, 4i divided by 2 is 2i, so we get that x is equal to 1 plus or minus 2i. Or if you want to split it up, it's 1 plus 2i or 1 minus 2i. Awesome! Now we can solve simple quadratic equations like these. But what if we want to take on a harder one? Let's try x squared plus 3x plus 4 minus 6i is equal to 0. So here we've got complex numbers in the equation itself. Now using the quadratic formula, we get that x is equal to negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times 1 times 4 minus 6i, all divided by 2. Now we can tidy this bit under the square root, and so we get x is equal to negative 3 plus or minus the square root of 9 plus negative 4 times 4, which is negative 16, plus negative 4 times negative 6i, which is 24i, all divided by 2. Now 9 minus 16 is minus 7, so we get that x is equal to negative 3 plus or minus the square root of negative 7 plus 24i, all divided by 2. So now we've got the square root of a complex number. But that's alright, we know how to do those now. And since this number happens to be the same one that we did in our example before, we even already know the answer. The square root of negative 7 plus 24i is 3 plus 4i and negative 3 minus 4i. But which one should we use? Well, in this case, it doesn't actually matter, because this plus or minus here is going to give us both 3 plus 4i and negative 3 minus 4i anyway. So let's just go with the positive 3 plus 4i. So now we get x is equal to negative 3 plus or minus 3 plus 4i, all divided by 2. And we're going to need a change of paper. Okay, we're back, and we've got x is equal to negative 3 plus or minus 3 plus 4i, all divided by 2. So we're going to consider the positive and negative 3 plus 4i's as separate cases. So we've got x is equal to negative 3 plus 3 plus 4i, all divided by 2. Or we've got x is equal to negative 3 minus 3 minus 4i, all divided by 2. So on the left-hand side, the negative 3 and the positive 3 are going to cancel out. So we'll just get 4i divided by 2, which is of course 2i. And on the right hand side, the negative 3 and the negative 3 are going to make negative 6 minus 4i all divided by 2. And negative 6 divided by 2 is negative 3. And negative 4i divided by 2 is negative 2i. So we end up with x is equal to 2i, or minus 3 minus 2i. Nice! Now we can actually solve any quadratic equations using the complex numbers. That's all, folks. Next time we'll be taking a look at the complex number plane. See ya!